What's up, y'all? It's Mr. Canada. In this video, we're going to be learning about the three forms of a function. More specifically, we're going to be talking about how we can convert an equation into a table and how we can take that table and convert it into a graph. Let's go ahead and get started. So what are the three forms of a function, and what do I mean by that? Basically, there are three ways that you can represent a function, and those three ways are the following. You can represent a function as an equation, like how we saw before with function notation. We can represent a function as a table, and we can also represent a function as a graph. Now, I like to call this the holy trinity of representations. In other words, we can take an equation and turn it into a table, we can take an equation and turn it into a graph, and vice versa. Using any table, we can turn that and make an equation out of it, and likewise, we can take a graph and also change that into an equation. Now, for the sake of this video, I'm only going to be focusing on taking an equation and turning it into a table, and then taking that table and turning it into a graph. There are a variety of different ways that you can write an equation from a table, but it depends on what kind of function we're working with. Which, since Algebra 1 deals with a variety of functions, the method is not always the same. So I'm going to leave that for future videos. So let's go ahead and learn how we can convert an equation into a table. Now, in the past couple of videos, you might have noticed that there's a calculator right above me. This is from the website called Desmos.com, and they have a really nice scientific calculator and a really nice graphing calculator. I definitely recommend that you use them in case you don't have a graphing calculator at home. They are pretty expensive, so it's nice to use the online resources that are given to us. So let's go ahead and start with our first example. Let's convert an equation into a table. Basically, the idea is simple. They're going to give you a table of inputs, and you're going to be taking those inputs and getting a variety of outputs out of them. So for example, let's say that they give us a function f of x equals 2x minus 1. If you want to write a table for this, let's go ahead and take these values and figure out some outputs. Now, do we always have to use these values of x? Absolutely not. Really, you could use any values of x you want to make any table. But just to keep it simple, I'm going to be using the ones that are given here. So, how exactly do we start getting our outputs? Well, from our function evaluation video, all you really have to do is take these inputs, plug them in, and simplify. I'm going to do it a couple of times, but then after a while, I will be using a calculator, okay? So, our first one, what we're going to do is that we're going to input -2. So f of -2 is equal to 2. Remember that our placeholder is here, -1, and we're going to put this input of -2 inside the placeholder. Remember that from last video. So 2 times -2 is -4, and then -1 will get you -5. That means that when x equals -2, y is equal to -5. Let's go ahead and try that out one more time. So f of -1, this time our input is -1, so 2 times -1 minus 1. Again, let's go ahead and simplify. So 2 times -1 is -2, minus 1 will get you -3. So that means when x is equal to -1, y is going to be equal to -3. Let's go ahead and speed this up a bit, and let me go ahead and show off the calculator that we're using here. So our calculator is as following. Let me go ahead and make sure we get the one. So basically, all you have to do is, what's really nice about this is that you can put parentheses and exponents and square roots, pretty much anything you want in this calculator. It's pretty nifty. So let's go ahead and use it. So 2 times, this time the input is going to be 0 from our table. And then we are going to do -1. What's really nice is that they even tell you that the answer is showing up on the side. So our answer is -1. So I'm going to go ahead and put -1 over here. Let's go ahead and keep trying this just so we can get a better idea how to use it. Okay? For a quicker way of evaluating, you could just take away that 0 and then change it with a different input. Like for example, the input this time is 1, so I can go ahead and type in 1 and look at my answer. It's equal to 1. We're going to put that there, and then finally, let's go ahead and take that input, and this time, let's change it into a 2. And notice what the answer is. It's just +3. And there you have it. This is a table that represents this function or this equation. It's pretty nifty, especially when you use a calculator like Desmos. Let's go ahead and keep doing this with the rest of the tables here. So, look at this next example. It's a pretty big one. Now, if you want, you could use a graphing calculator again, or the calculator that was shown on the screen right above me, or you could do it by hand. It's totally up to you. For the sake of simplicity, and because sometimes it does get a little bit repetitive, I'm going to go ahead and just show you one example of how to use function notation, and then the rest of it I will go ahead and just use a Desmos calculator. So this time our function is f of x is equal to x squared plus 2x plus 1. Our input is the same as last time, so we're going to go ahead and plug in -2. So this is going to be -2, and remember that we're going to go ahead and plug in -2 wherever we see an x in our equation. So this is going to be placeholder there, a placeholder right here, and then we're just copying down the +1. So that means -2 is going to go in here. So let me go ahead and change the color up here a bit. -2 and -2, and now all you have to do is simplify. So -2 squared, which is basically -2 times -2, is +4, plus 2 times -2 is -4, and then you bring down that +1. These two cancel because they're opposites, so that's just 0, and then +1 just gives you a final value of 1. So that means when x is equal to -2, y is equal to 1. Now, if you're not sure about that, we can use a Desmos calculator. So let's go ahead and try it out one more time. This time, my equation is different, so that means I'm going to be changing this up. So we have placeholder. Let's go ahead and plug in -1 this time. -1. Now, if you want to put a squared here, all you have to do is click at the square button right here, and it'll square it for you, which is pretty cool. Plus 2 times, you can put parentheses here, -1 again, because that's what we're plugging in, so -1, close the parentheses, and then this time add the +1. So +1. And notice what your final result is. It's going to be 0. So that means that here, we're going to go ahead and put 0. Let's go ahead and evaluate 0, 1, and 2. So from here, what we're going to do is we're basically just going to change the input to the new input. So this time this is going to be 0, and then this one is also going to be a 0. What's our result? It's +1. So here, this is going to be a +1. And then we're just going to keep changing it. Here this is going to be a 1. This is also going to be a 1. And our final result is a 4. We're going to change this into a 2. We're also going to change this into a 2. Our final result is 9. So that means that here, our final result was 4, and the result for this one was 9. There we go. We completed the table using the Desmos calculator. Now, if you have a calculator at home, like let's say one on your phone, you can also do it. Just make sure that it's on scientific, because if you use a basic form function, it probably won't put in the parentheses in the right way. Same thing with the exponent. Okay, one more example here. We have f of x equals 2 to the power of x. This one's a little bit different from the other ones because the variable this time is in the spot where the exponent is supposed to be. So let's go ahead and see how that's going to work. So f of -2 is equal to, well, my placeholder is up here. So that means that I'm going to go ahead and put the input up here. And then we're going to evaluate. Now, we're going to be using the Desmos calculator just to make the work a little bit faster now. So in this case, let's go ahead and erase all this. 2, if you want to put an exponent on Desmos, you're going to be clicking on this button. See, it erases the little line up there. In this case, what we're going to put is the parentheses, and then we're going to type in -2, and then close the parentheses. Look at that, 0.25. Here's another really cool thing about Desmos. If you click on this one, it'll convert any decimal that you have into a fraction. So it's pretty useful in case your math teacher prefers to use decimals, or whether you prefer to use fractions. It's totally up to you. So in this case, I'm going to go ahead and leave it as a fraction. I'm going to say that this is 0.25. Let's go ahead and go through the rest of these real quick, just so we can get on with the next part. So here, we're going to go ahead and test it out for -1, which is 0.5. We're going to put in 0 next, which is 1. So let's go ahead and do it at a time. 0.5, and then this is 1. And then finally, let's go ahead and get our last two answers. Here we can put 1, which is an answer of 2. And if we put 2, It's an answer of 4. So here it's going to be 2, and here it's going to be 4. So this is a really nice tool that you can use in case you don't own a calculator, or if the calculator on your phone is kind of weird. Now, how do we take these tables of values and convert that into a graph or into a shape that we can visualize the shape? Well, this is where the next part comes in. All you have to think about is this. These are inputs and outputs, but more importantly, they're x and y's, which you can make them into coordinate points. So, well, that's exactly what we're going to do here. But to be honest with you, I really don't want to be copying everything. So, I'm going to be using some movie magic in just a second to make all of the points disappear. So, and there you have it. We have all of the points that we got from the previous tables. How did that happen? It's called movie magic. So, what's the game plan from here? Now that we have a whole bunch of x and y values, really all we're going to do here is just convert these into points. So for example, this is the coordinate point, -2, -5. And we can do the same basically for each single one. And all we have to do is take those points, plot them, and see what kind of shape they make. So for this one, this is -2, 5. So this is -2, and we're going up to 5. 1, 2, 3, 4, 5. This one is -1, 3. So we start at -1, we go up to 3. And all we have to do is just take these points and go ahead and plot them onto the graph. So from here, this is -2, -5. So -2 is right here. We always start with the x, and then we go down to the y. So 1, 2, 3, 4, 5. The next one is -1, -3. So that means this one we start at -1, so then we go down to 3. 1, 2, 3. Next one is 0, -1. 0 is at the origin, and then it's -1 on the y. So then we put a point right here. Next one is 1, 1. We go to the x at 1, and then we go up 1. The next one is 2, 3. Here's the 2, then we go up to 3. Notice what kind of shape they make. They make a line. Hopefully your lines are better than mine. So this is going to be a straight line. Now this is an example of what we call a linear function, because it creates a line graph. Let's go ahead and see what other functions we can make out of this. So here's an example here's a second example. We're going to take these points and go ahead and plot them. This one's going to be -2, 1. So here's -2, and then +1. The next one is -1, 0, which would be right here. 0, 1, so that's at the origin, and then we go up 1. Next one is 1, 4. Here's 1 for x, and then we go up 4 for y. And then it's 2, 9. Here's the 2, and then we go all the way up here to 9. And notice what kind of shape they make here. Now we could go ahead and try to replicate this, and then it'll be the same on both sides. We don't really create a line here. We actually kind of create a curve. Now this curve is what we call a parabola. And parabolas deal with a very special kind of function. They're called quadratic functions. So this is another function that we're going to be talking about in Algebra 1. Let's go ahead and look at our last example. Our last example is 2 to the power of x. Just like before, I already have all the points. Let's go ahead and plot them. -2 and then 0.25. You're going to have to do a little bit of guesswork here, or try to do your best to plot a point that's right there. It's kind of below 1 and it's right above 0. It's a really small number. Next one is -1, 0.5. We can see that's just a little bit above this one. Next one is 0, 1. So we start at the origin and then we go up to 1. Next one is 1, 2. So here's 1 and here's 2. And then the next one is 2, 4. So here's 2. And then we go up to 4. Now if we were to connect these, we would create this kind of graph. Now this graph is what we call an exponential curve. Exponential curve. And these types of graphs deal with exponential functions, which is the third type of function that you'll see in an Algebra 1 course. So what's the idea? The idea is that as long as you have a table of values, you can take those points and plot them onto the graph and see what kind of shape they make. Now, If you have an equation, you can always convert them into a table by just evaluating them either by hand, mentally, or using a calculator. And the three types of main functions that you'll see in this course are linear functions, quadratic functions, and exponential functions. Well, I hope you guys learned something new today. If you liked the video, give this video a like and subscribe to my channel for more Algebra 1 videos. If you have any questions, go ahead and post them in the comments below and I'll get to you as soon as I can. And like always, please take care and I'll see you guys next time.